We chose the simulation that teaches the basics of force and motion, specifically net force. At its core, it is an important simulation that teaches about the fundamentals of Newton's first and second laws of motion. This is a simulation representing a tug-of-war where each person has a different force value that they can apply onto the rope. The box in the top right corner allows us to see what the sum of forces are, the values of force for each person, and the forces in each direction. There is also a speedometer on the cart that shows when speed increases, decreases, or remains constant. Newton's first law states that an object's motion cannot change unless an unbalanced force is acting on it. Newton's second law states that the sum of forces acted on an object is equal to its mass times acceleration. This simulation measures the sum of forces and shows an increase or decrease in speed. The only unit that is measured in the simulation is newtons, which applies to force. Newtons is the standard SI unit for force, and it is used to measure the pushing or pulling force that can cause an object to accelerate.
The simulation allows us to play through 4 different scenarios. In the first scenario, if we make the forces on both sides of the cart 50 newtons, we can see that the sum of forces is balanced. Therefore, the acceleration is 0 and there is no movement in either direction. In the second scenario, as we increase the force on the left side to 150 newtons, we create an unbalanced force. Since there is a net force of 100 newtons pointing towards the blue team, movement is created towards the left with an increase in speed over time. Conversely, in scenario 3, if we increase the force on the opposite side to be greater by adding 150 newtons to the red team, we can change the direction of the cart's motion. You will notice that the speed of the cart decreases to 0 before the change of direction and increases over time in the new direction. In the fourth scenario, if the cart moves towards the red team due to an unbalanced force, and then we balance the forces by adding 50 newtons to the blue team, the net force will be equal to 0. The cart is now experiencing equilibrium because it is moving at a constant speed with an acceleration of 0. By playing out these scenarios, the simulation lets us see how Newton's first and second laws can affect an object's motion, such that an object's motion does not change unless acted upon by an unbalanced force, and that the net force is the result of an object's mass times its acceleration.